All right, in this video is the continuation of section 13.1 dealing with representations of lines. We already talked about slope and how to calculate slope and other things. Now here we're going to make a connection between slopes and parallel lines, and also we're going to be making connections with slopes and perpendicular lines. So we're going to start off with parallel lines, how slopes are connected to them. Lines in the same plane are said to be parallel if and only if they do not intersect. Okay, so if two lines do not intersect, like these two right here, that means they're parallel. And let's say you know two lines are parallel. In this next example, this explains why both lines must be vertical lines, horizontal lines, or oblique lines. So when two lines are parallel, there is no mixing of the types of lines. So in part A of this example, explain why the vertical line x equals a must intersect the oblique line y equal mx plus b. And part B, explain why the horizontal line y is equal to c must intersect the oblique line y equal mx plus b. And explain this part C, explain why the vertical line x equals a must intersect the horizontal line y equals c. So let's start off with part A, explaining why the vertical line x equals a has to intersect the oblique line. X equals a is what we're going to have here, and y is equal to mx plus b must represent the equations for horizontal and oblique lines, respectively. If we replace the x with the a in the equation y is equal to mx plus b, then y is equal to m times a plus b. Okay, so this x is being substituted with the a in this case. And then the point A, comma, MA plus B belongs to both lines. So that means that the horizontal line must intersect the oblique line. Now, part B, we have y equals C and y equals mx plus b. Y equals C is the equation for, well, they must represent equations for vertical line, and the y equals mx plus b represents the oblique line. If we replace the y with a c in that equation, then this is what we're going to have. C is equal to mx plus b. And then if you solve for x, we have to subtract b on both sides and then divide both sides by m to get this. X is equal to c over b, that quantity divided by m. So the point c minus b divided by m, comma c belongs to both of those lines. So that means the vertical line has to intersect the oblique line. And let's say we have x equals a and y equals c. X equals a represents a horizontal line. The vertical line. Y equals c represents a horizontal line. So that means the point a, comma c belongs to both lines. And I can do a visual representation of that. So here's a vertical line. And then you got the horizontal line. Pretty much you can see there's the intersection. So that vertical line does intersect the horizontal line in this case. Okay. Now, in this case here, these two figures will help you conclude the following. The one on the left, we have L1 and L2. They both have a slope of 2. So that means L1 and L2 will have to be parallel lines. Those lines do not intersect. So if the slopes of two non-vertical lines are equal, then the two lines are parallel. Now, the second situation is this. If two non-vertical lines are parallel, as in this case right here. So you are told that L1 and L2 are parallel to each other. So that means the slopes have to be equal to each other. Now, in this example, two lines are parallel, and in part A, the slope of one line is 3/2. What is the slope of the other line? And in part B, the equation of one line is y is equal to 5x plus 2. Write a possible equation of the other line. Okay, so that means let's answer part A of this example. The slope of one line is 3/2. What is the slope of the other line? Well, two lines are parallel lines. They mean they don't intersect each other. And if you have two lines that are parallel, that means they have the same slope. So the slope of the other line has to be 3/2. Okay, now part B, you're given the equation of one line being y equal 5x plus 2. And I want to write a possible equation for the other line. Well, the slope in part B was 5. That's the coefficient of your x term. That would mean all the equations must have this form. Y is equal to 5 times, which is your slope, then x plus some b. And b can be any number. Now, a possible answer for that would be y equal 5x plus 8. Or it could be y equal 5x minus 2. Those are possible solutions or possible answers for the equations, because all the equations have to be in this form with the slope of 5. Okay, here's another example. The equation of the line N is this: y is equal to 2x plus 7. And I want to write an equation of a line parallel to line N and passing through for -1. Well, here the equation does have the form y equal 2x plus b. That's because if we have two parallel lines, that means the slopes have to be the same. So if the slope here of this line is 2, that's one the coefficient of x, then the slope of the line parallel to it has to be equal to 2 as well. And here the line passes through the point 4, -1, so we need to find some b that will satisfy this equation. So here, this is x for the 4, the -1 is y. So we got -1 is equal to 2 times 4 plus b. Here we're using that y equal mx plus b formula. And substituting the y with -1, your slope is 2 times x, which is 4, plus b. And then that means 2 times 4 will be 8, so -1 is equal to 8 plus b. And then we subtract 8 to get b by itself, to get b is equal to -9. And using y equal mx plus b, this will be your equation. Y equals 2x minus 9. Okay, so now we can summarize the connection between slopes and parallel non-vertical lines in these two theorems here. If the slopes of two non-vertical lines are equal, then the two lines are parallel. And then theorem 2 is just the converse of the first theorem. If two non-vertical lines are parallel, then their slopes are equal. Okay, now take a look at problem number 13 on page 781. Here we're going to determine the equation of the line that is parallel to this equation, y equal 3x plus 4, and passes through the ordered pair 5, 2. So, our equation is y is equal to 3x plus 4. It is in slope intercept form, as you recall. That means we can identify the m. The m is the coefficient of x, which is 3. Now, we're told that the line that we're looking for is parallel. So if this slope of this line, which I'm going to call M1, is 3, then the slope of the second line has to also be equal to 3. Okay? Parallel lines have the same slope. So now, we're going to use the y equal mx plus b. And I know my ordered pair is 5, 2. So this is x and that's y. And we just substitute. We're going to substitute m2 and then x and y in that equation. So here the y is equal to, in this case, 2 is equal to m, we're using 3, times x, which is 5, plus b. Now 3 times 5 is 15, so we got 2 is equal to 15 plus b. And then to solve for b, we subtract 15 on both sides. So that means b is equal to 2 minus 15 is negative 13. So the y-intercept would be negative 13. So using that y equal mx plus b, we just substitute the m and the b. So that means we're going to get y is equal to 3x plus a negative 13 will end up being minus 13. So this is the equation of the line that is parallel to y is equal to 3x plus 4 and passes through the point 5, 2. Okay. Right. Next, we'll talk about connections between slopes and perpendicular lines. So now we're looking at perpendicular lines and how that's connected with the slope. If two lines are perpendicular, then the product of their slopes is negative 1. Or one line is horizontal and the other line is vertical. Okay? That's just the rule for that. Now, in this example, excuse me, two lines are perpendicular. So in part A, the slope of one line is 3/2. What is the slope of the other line? Then part B, the slope of one line is 0. What is the slope of the other line? So here in part A, the two lines are oblique because we have a slope of 3/2. Now the slope of that other line will have to be what we call the negative reciprocal of that slope. So if that slope is 3/2, so here we take the reciprocal and change the sign. The reciprocal of 3/2 is 2/3. And then since that 3/2 is positive, we change it, we make the 2/3 negative. And that's because if you take the product of these two slopes, multiply 3/2 times negative 2/3, it has to be equal to negative 1. So if you do 3/2 times negative 2/3, divide the numerator and the denominator by 3, excuse me, you'll end up with negative 1, a product of negative 1. And now part B. The slope of one line is 0. So what is the slope of the other line? Okay, so here in this case, if the slope of one line is 0, then that means we have a horizontal line. So with a slope of 0, that line is horizontal. So that means the other line has to be vertical. That would mean the slope would have to be undefined, as I talked about in the last video for finding an undefined slope. So that means with an undefined slope, that means it does not have a slope. Well, it does, but it's actually undefined. Okay. On this next slide, now suppose that the slopes of two oblique lines are M1 and M2, such that M1 times M2 is equal to -1, or one line is horizontal and the other line is vertical. Are the two lines perpendicular? Now he can use a protractor to measure the angle formed by the two lines here. So here we got L1, which is this blue line, and then L2, which is the red line, for which the product of those two slopes is going to be equal to -1. Okay. And if you were to use a protractor here, you'll see that those two lines are going to be perpendicular to each other. They're going to form what they call a 90-degree angle. Let's say I want to complete this conjecture. If the product of the slopes of the two lines is -1, or one line is horizontal and the other line is vertical, then we can say here that the two lines are perpendicular. Okay? So here we're going to complete that sentence with this phrase. Then the two lines are perpendicular. If the product of the slopes of two lines is -1, or one line is horizontal and the other line is vertical, then the two lines are perpendicular. So look at this example here. Here I want to determine whether the graphs of one of the lines with the given equations are perpendicular. Starting with part A, we got y is equal to -3/5 x plus 1 and 3y minus 5x is equal to -36. Okay. The first equation has already got y by itself. The second equation does not. We need to get rid of the 3 that's in front and move the 5y over to the other side. I'm going to do this off to the side so you'll see what they did here. So to get the 3y by itself, we're subtracting 5x, so I need to add 5x. So that means I got 3y is equal to 5x minus 36. And then divide each and every term in that equation by 3, you'll get y is equal to 5/3 x minus 36 divided by 3, that's minus 12. That's where this equation came from. And now we can identify the slopes because it has to be in slope-intercept form where you're solving for y. So for this first equation, y equals -3/5 x plus 1, the slope there's the coefficient of your x. That's -3/5. And for this equation, y equals 5/3 x minus 12, its slope is 5/3. So now if you take the product of those two slopes, -3/5 times 5/3, you will end up with -1. So here we can conclude that the two lines are perpendicular. And then part B, I'll bring this back down, was y equals -7x plus 1 and y equals 2x plus 8. Well, this first equation has a slope of -7, and the second equation has a slope of 2. If you multiply -7 times 2, that will give you -14. And unfortunately, -14 does not equal to -1. So that means that those two lines are not perpendicular. Okay? The product of the two slopes, multiply the first slope and the second slope, they must be equal to -1. Otherwise, they're not perpendicular. Okay, so here's the connection between the two. Here's theorem 3 and 4. Theorem 3 says here, if two lines are perpendicular, then the product of their slopes is -1. Or one line is horizontal and the other line is vertical. And then theorem 4, if the product of the slopes of two lines is -1, or one line is horizontal and the other line is vertical, then the two lines are perpendicular. Okay. Take a look at problem number 11 on page 781, because we're going to do something like this one. Determine whether the lines are parallel, perpendicular, or neither. So for two lines to be parallel, the slopes must be equal to each other. For the two lines to be perpendicular, the product of the two slopes must equal -1. Otherwise, it's neither. So I'm going to start with part A. And in this case here, we got y is equal to 5x minus 2 and y equal 10x minus 4. And I want to determine whether those two lines are parallel, perpendicular, or neither. Okay. I'm doing this on a separate sheet of paper, so here it is. Now, in this case, they're both solved for y, so I can identify the slope and the y-intercept. Well, just the slope of each one of those. So that first equation, y equal 5x minus 2, I'm going to let this be m1. It's the coefficient of x, that's going to be 5. And for the second equation, y equal 10x minus 4, m2, which I'm going to call that's going to be 10. Now for the two lines to be parallel, the slopes have to be the same. Here, 5 and 10 are different, so we know they're not parallel. What about perpendicular? Well, if I take the product of these two, that's 5 times 10, that's 50. So here, that's not equal to -1. So here, we know M1 and M2 are not the same, so they can't be parallel. The product of these two gave me 50. It's not equal to -1. So the final answer has to be neither. Okay? Those lines are neither parallel nor perpendicular. Okay. Oh, let's go on to part B. We got y equal 2x minus 6. And 2y plus 4 is equal to 12. 2y plus 4x is equal to 12. We want to determine if those lines are parallel, perpendicular, or neither. That first equation is solved for y, so I can easily identify the slope. I'm going to call this M1. That's the coefficient of the x term. That's 2. The second equation, I need to get the y by itself. So I need to move the 4x first over to the other side by subtracting 4x on both sides. So here I got 2y is equal to -4x plus 12. And then to solve for y, I need to divide each and every term in this equation by 2. So here I'm going to have y is equal to, here negative 4 divided by 2 is negative 2, so that'll be negative 2x plus 12 divided by 2. That's 6. So now I'm going to label this as m2, the slope of the second equation. That's negative 2. Now let's compare those. For it to be parallel, both slopes, the slope of both of these have to be the same. You can see they're not. M1 and M2 are not the same. I got 2 and negative 2. They're different. So they're not parallel. What if I take the product of these two slopes? 2 times negative 2, that's negative 4. The product of the two slopes must be equal to negative 1. And negative 4 is not equal to negative 1. So those two lines are not going to be perpendicular. So that means, again, this is also neither parallel nor perpendicular. Okay. All right, on to part C. Is y is equal to 10x minus 2 and y plus 10 equal to 0. The first equation is solved for y, so I can identify that slope directly. So I'm going to label this m1, that's the coefficient of x, that's 10. Let's get y by itself. I'm adding 10, so I need to subtract 10 on both sides. So this will be y is equal to negative 10. Well, notice y is equal to a constant. That means the slope is automatically going to be 0. Now, if you wanted to, you can write that as y is equal to 0x minus 10. And you'll see that your slope is automatic. It's going to be 0. Because y is equal to negative 10 is a horizontal line. And in a horizontal line, your slope is automatically 0. Now I need to determine whether they're parallel. Well, you can see that M1 and M2 are not equal to each other. So they're not parallel. What about the product of the two? They must equal to negative 1. Well, M1 is 10 and M2 is 0, but 10 times 0 is 0. That's not equal to negative 1. So again, it's neither parallel nor perpendicular. Okay, now part D. Here we got 4y plus 3x equal negative 18 and 3y equals 4x plus 7. The first equation I need to solve for y. I'm adding 3x, so I need to subtract 3x on both sides. So I got 4y is equal to, I'm going to put the negative 3x in front and then minus 18. And then to solve for y, we divide each and every term by 4. So here this will be y is equal to, I'm going to say negative 3/4 x minus 18 over 4. I can reduce that by dividing the numerator and the denominator by 2. So 2 goes into 18 9 times, and 2 goes into 4 2 times. So I got y equal negative 3/4 x minus 9/2. So here, the slope of the first equation is the coefficient of x, negative 3/4. And the second equation, 3y equal 4x plus 7. Well, we need to solve for y by getting rid of that 3 that's in front. So I need to divide each and every term by 3. So that means y is equal to 4/3 x plus 7 over 3. So now the slope of that second equation, m2, is 4/3. Now, if we look at these slopes here for m1 and m2, they're not the same. So we know they're not going to be parallel. Now, if I do m1 times m2, that must equal -1. The product of the two slopes must equal -1 in order for it to be perpendicular. So if I do -3/4 times 4/3, that should equal -1. Well, these 4's divide out, the 3's divide out, I'm left with a -1. And that does equal to -1. So that means the slopes, well, the two equations are perpendicular to each other. The two equations are perpendicular. The lines of those two equations are perpendicular, I should say. And then finally, part E. Here we got 5y equals 7x plus 2. And y is equal to 5/7 x plus 12. The second equation is solved for y. The first equation, we need to get y by itself by dividing each and every term by 5. So here we've got y is equal to, this will be 7/5 x plus 2/5. So the slope of the first equation is the coefficient of x, that's 7/5. And since this is solved for y, the slope of the second equation is 5/7. Okay. If you look at this, the two slopes aren't equal to each other. So we know m1 is not equal to m2. They're not parallel. The product of the two, for it to be perpendicular, the product of the two must equal to -1. So if we have 7/5 times 5/7, they must equal -1. Divide the 5 out, divide the 7 out, you're left with 1. And that does not equal to -1. This is going to be neither parallel nor perpendicular to each other. Okay, so keep in mind, for you to have parallel lines, both slopes must be equal to each other. And for perpendicular lines, the product of the two slopes must equal -1. Okay, so let's take a look at this example of writing an equation of a line. All right, here we're going to determine the equation of a line that is perpendicular to the equation 3y equal -8x minus 5 and passes through the point 1, 4. Okay. First of all, we need to solve this equation for y before we identify the slope. I'm going to do that by dividing each and every term by 3. So this is y is equal to negative 8/3 x minus 5/3. And from that, I'm just going to identify the slope. I'm going to call this m sub 1, which is, of course, negative 8/3. The m2 is going to be the slope that is perpendicular to this line. This is where we take the negative reciprocal to find out that other slope. So the slope of the first line is negative 8/3. The slope of the other line that's perpendicular to it would be this. We flip this over, this will be 3/8. And since it's negative, we keep the 3/8 as a positive number. And that's because the product of these two must equal to negative 1. And since that first slope was negative, the second slope perpendicular to it has to be positive. And we take the negative reciprocal. So it's the 3/8 that we're going to use. And the ordered pair 1/4. We're going to use that in this equation. Y is equal to mx plus b. And that 1 is your x, the 4 is the y. We just substitute that in this equation. Your y is 4, so b4 is equal to, the slope is 3/8 times x, which is 1, plus b. And 1 times 3/8 is 3/8. So that 4 is equal to 3/8 plus b. And to solve for b, we have to subtract 3/8 on both sides. So that means b will have to be equal to, and here I'm going to have to use the calculator. So here we got to do 4 minus 3/8. So this will be 4 minus, and in parentheses, 3 divided by 8. And then I'm going to use this math key. I need to bring this up a bit. The math key is over here. Select number 1 for fraction. That'll be 29 over 8. And that's your y-intercept. Here, I got the slope of 3/8. The y-intercept of 29 over 8. So my equation, I'm going to write this down here. That's y is equal to m, that's the 3/8, x, plus 29 over 8. That represents the equation of the line that is perpendicular to 3y equals negative 8x minus 5 and passes through the point 1, 4. Okay? So that's going to conclude this section on 13.1, representations of lines. And the homework will be available on WebAssign for you to complete. Make sure you have that done. And please feel free to answer any questions ask me any questions if need be. So the best way to contact me is through email.